So scientific notation is a useful way for us to simplify and write numbers using powers of 10. So you can see this big long number right here, it's big and messy. We can simplify that in a much easier way. So when you write scientific notation, you need to write the numbers as a product of two factors, and I'll show you what I mean. So first thing we need to do is count the distance from our last number to what would be a decimal place. Now, of course, the decimal isn't shown there, but you know that after that last zero is a decimal because I could go like this and go on with the tenths, hundredths, and thousandths place. But since those aren't there, I am going to count how many places to the left from the decimal. So I'd say it's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 places. So I'm going to write that 9 right here so that I know I moved 9 places. Now, since what I did was by counting, what I was doing was counting how many times that decimal needed to move to the left. So this is now, instead of 7 and a 5, it's actually now 7.5. Imagine that decimal's there. So I'm going to write that, 7.5. Now, obviously this number is not 7.5. And it's not 7.5 times 9. However, it is 7.5 times something to the ninth. Now remember what we learned about exponents. To the ninth power means times itself 9 times. So what times itself 9 times would give us all these zeros and move our number that many places? What about 10? So if I did that, it would look like 7.5 times 10 to the ninth. And this is the only time we use x for multiplication in our class. Only time. Now, if you remember what I said just about a minute ago, I said it's the product of two factors. Factors, think about this. If I said, what are the factors of, let's say 6, you would say 2 times 3. Same idea. Right here I have 7.5 times 10 to the ninth. Those are two different factors. So the first factor has to be greater than or equal to 1, but less than 10. And this one, the second factor, is a power of 10, meaning this will always be, remember, power of 10, like the 10 to the ninth power. Now that number right here, the power could always change. It could be any number. This first factor, it's important to note that scientific notation always has to have something in the greater than 1 or less than 10. Okay? So let's say I had 3 times 10 to the fourth. So what would I do to expand that out? This is currently in scientific notation, how would I write that in standard notation? Well, you start off by writing 3. Now 3 is like the same thing as saying 3.0, correct? So 3.0, now times 10 to the fourth. If it's in scientific notation, that tells you how many places you're going to move the decimal. So in this case, I'm going to move it 4 times. So I'd say 1, 2, 3, 4, and fill in the zeros. Now this number, so imagine there's a big decimal place right there. This number is now 30,000. Okay? Okay, now I want you to try this one. Look at it for a second. It says 5.8 times 10 to the third. Now, what do you do first? You know you have 5.8, okay? Times 10 to the third means it's going to move what? The decimal should move 1, 2, 3 places, and then we'll put in those zeros. Our new number is 5,800. Pretty simple, right? So now I want you to write this number in scientific notation. It's currently in standard. Now what you have to do is look at it and pause for a second if you need to, but look at it. What do you need to do? Okay, imagine you had that little decimal right there. Now, like I said, our number in scientific notation, the factor needs to be equal to, or greater than or equal to 1 and less than 10. So we need to move this 1, 2, 3, 4 places to the left. So we know that it's to the fourth power. And we know that it's what to the fourth power? 10 to the fourth power. Okay. And again, this is the only time I allow you to use x. Now this number, we should say, is 2.48. Now to write it properly, we'd say it's 2.48 times 10 to the fourth. So what do you do if you come across something like this in scientific notation? It says 5 times 10 to the negative third. Okay, but this is not a negative number. Think about what you know, what you've previously learned about exponents. 10 to the negative third does not mean negative 1,000, does not mean negative 1,000,000, it does not mean 1. What does it mean? That's like we said this, 10 to the negative third is equal to 1 over 10 to the third, remember? Well, 1 over 10 to the third is what? That's 1 over 1,000, correct? Okay, that's like now saying 5 times 1,000th. What does that mean? Well, we start with 5, and 5 is a decimal like that, right? We would move our decimal now to the left 3 spaces. So we say 1, 2, 3, then we plug in those zeros there. Our new number is 0.005. That's not a negative number. What I did was I kind of just divided it down. Think about like when we learned with exponents that it's not a negative number, that it's more like division. Let's do one more. We have 2.4 times 10 to the negative second. So this is not a negative number. What do? Move it 2 places, add that 0, so now I say 0.024. That's my number now in standard notation. Okay, so now I've got this decimal in standard notation. I want to put it in scientific. Obviously, as you know, we need to have this right here. The number needs to be 4.6 to be proper. I need to move that decimal 3 places. Now we say it's 4.6. Now, is it times 10 to the third? Or what did we just learn about what decimals mean? It should be negative third.